Hi everyone, welcome back to Geeks for Geeks. My name is Yash Dwivedi, and in this video we'll discuss the problem sum of products. So let's read the problem statement and see what the problem says, and then we'll think about a solution for it. So the problem says that you'll be given an array of n size and you have to calculate the sum of bitwise ands. That is, calculate the sum of bitwise and of the ith element and the jth element for all the pairs in the given array such that I is less than j. So what does this mean? Suppose that there is any particular element I at the index I and another element at the index j. So the I index should be less than j, and I have to take the and. So I have to do what? The ith element that is there, AR of I have to do and of it with the jth element, that is AR of j, and I have to do this for all the pairs. And then we have to return the sum of this particular thing. So how can we do it in a very basic format? So in normal terms, we can simply say that we can initially mark our sum variable, let's say, as 0. We can initially declare sum as 0, and then after that we can iterate through the index. Let's say I starts from 0, I is less than n, then we can do I plus plus. After this, since our j is always going to be greater than I, so we can start our j from I plus 1 till j is less than n, and then we can do j plus plus. In this way, we will be able to generate all the pair of indexes I comma j such that I is less than j, and we will be able to take the and of AR of I and AR of j, and then we'll be able to take their sum. So what we can do is we can say that sum plus is equal to what? ARR of I and with ARR of j. Okay. This is how in a brute force manner we can generate the sum of and for all the numbers, right? For all the pairs such that I is less than j. Because if the question wanted me to choose an ith element and a jth element such that I index is less than j, and I had to take the and of the ith and the jth element, so we can simply run a loop I from 0 till less than n, and we can start our j loop from where? We can always start our j loop from the index I plus 1, then j is less than n, j plus plus. Now in this case all the i's will be less than j, and we can take the and of AR of I and AR of j. Okay, now in this particular case, if you will see, so we had to return the sum of all of it. So then our code will work because we have done it in a brute force manner. What will be the time complexity of such kind of approach? The time complexity will be nothing but order of n square. Why? Because we are running two loops. Instead of that, can we do something better? Yes, whenever we have a question where we have to deal with and or XOR anything, then we can always use the bit manipulation approach, or we can always deal in terms of bit in order to decrease the time complexity of our code. So suppose that if we have got the elements, that is 5, 10 and 15. Suppose these elements are there. Okay, suppose the elements are 5, then you have got 10, and then you have got 15. Okay, if these are the elements that we have, so 5 is represented as what? 5 is represented as, let's say, 101. Then what is 10 represented as? 10 is represented as 1010. Then after that, what is 15 represented as, guys? 15 is represented as nothing but, you can say, 1111. Let me check. 1 2 4 8. So 8 4 12, 12 to 14, and then 115. Yes. So now what will happen here is it will be 1111. Now in this particular case, if you will observe, so you can see that this particular rightmost bit, that is the least significant bit, it is 1 in 15 and it is also 1 in 5. Okay, so whenever I will be doing the and, we will get what? Like we will get 1 here. Whenever I'll be doing 5 and 1, we'll get 1. So what we can do is for every position, because there are 32 bits, so from the 0th bit till 31st bit we can iterate, and for every bit we can count that how many numbers are having that particular bit as set. For example, if you will see here, so what will be the count for the 0th bit? If I is equal to 0, suppose for the 0th bit, how many numbers are there that have the 0th bit as the set? So 2 numbers are there that have the 0th bit as set. Okay, so now how many pairs will be made? If I have to make pairs, because if 2 numbers are there that have the ith bit as set, so suppose that if in general there were how many pairs? Suppose that for a particular position k numbers were there that had the ith bit as set. So if I am always out of these k, I will always be taking 2 elements. So that will be nothing but kc2, because I'll be using combination. So kc2 is nothing but k into k minus 1 by 2. So you can say that these many pairs will be made. Now what do I mean by this? Suppose that for a particular ith bit, okay, suppose that for a particular ith bit, if there was a number A, B, C and D, there were 4 numbers which had that bit as set. So suppose that the counter was what, or suppose that the k was equal to what, suppose that the k was equal to 4 here. So if the k was equal to 4, in that case, how many pairs will be made? How many pairs will contribute to the answer? So you can say that A comma B will be there, then A comma C will be there, then A comma D will be there. Then after that, what will happen? B comma C, then B comma D will be there. And then what will happen? C comma D will be there. So total 6 pairs are there. That is nothing but, as I said, KC2. So 4C2 is what? KC2 is nothing but K into K minus 1 by 2. So when you will do this, so 4 into 4 minus 1, that is 3 by 2 will be nothing but 6 here. So you can see that you are getting how many pairs? You are getting nothing but total 6 pairs here. Right, so I hope that you have understood this particular thing. So whenever you are at a ith position, so you will check that how many numbers are there that have the ith position as set. Suppose that for a particular ith bit, k numbers are there that have that particular bit as set. So whenever I'll be doing the AND of all these pairs, then for all these pairs, you will get that much impact. So suppose that you are at the ith bit. So what will be the impact of the ith bit? It will be nothing but 2 to the power I, because if I am at the 0th bit, so its impact is 2 to the power 0. If I am at the I is equal to 3 bit, so its impact will be 2 to the power 3, that is nothing but 8. Because we do it like this now, 1, 2, 4, 8, 16. So whenever this bit is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. So if I am at I is equal to 3, so its impact will be 2 to the power 3. Okay. So if 6 pairs are going to be there, suppose, right, then what will be the total impact for because of it for one particular number if that bit is set? So that will be 2 to the power I. But since I will be making 6 different pairs, so 6 times it will get set. So that will be nothing but 2 to the power I into 6. Right, so that is how we'll update. So what we are going to do here is we will simply iterate for all the positions, and whenever I am at the ith position, so I will check that how many numbers are there that have the kth bit like ith bit as set. Suppose k numbers are there, so the number of pairs that I will make is k into k numbers are there that have the ith bit as set. So the number of pairs that will be made out of that is k into k minus 1 by 2, in which the ith bit will be set. So inside my sum, I can say that the impact of this position is 2 to the power I, and it is present in these many pairs. So that is why suppose that 3 pairs are there that have the ith bit as set. So the impact of it will be what? Suppose that I is equal to 3, guys. If I is equal to 3, so its impact is 2 to the power 3, that is 8. And if suppose 2 pairs are there that have this particular bit as set after doing AND, so then you will be doing 8 into 2, that is 16, because the total impact in the sum will be 16 because of that particular position. So that is how our sum will get developed, and at the end of the day we can simply return our sum very easily. So what we can do here is we can simply start a loop right away, and whenever we are starting this loop, so we can simply say that long initially we can mark the sum as 0, and then after that we can iterate. So let's say int I starts from 0 till I is less than equal to 31, then I plus plus. So we'll iterate for all the bits from 0 till 31st bit, because total integer is 32 bit. Then after this, what we can say is that we will initially mark our number of set bits for that position as 0, and after this we'll iterate through all the numbers, and we'll check how many numbers are there, how many elements of the array are there that have the ith bit as set. So we'll first of all get a counter for it. So if it happens that ARR of J right shift I and with 1, okay, if this particular value is what? If this particular value is equal to 1, then in this particular case you can say that in the element ARR of J the ith bit is set. Then we will do what? We will count it. So after this particular internal loop is over, then I will be able to count that how many numbers are there that have the ith bit as set. Once I have that, so then I can say that the number of pairs that I will be making is what? Long let's say pairs will be equal to the number of pairs in which that ith bit will be set will be nothing but k into k minus 1 by 2. Why it will be k into k minus 1 by 2? Because if k elements are there that have the ith bit as set, so since k elements are there and I have to select 2 only, so it will be kc2. Kc2 is nothing but k into k minus 1 by 2. And now once I have got those pairs, so I will say that inside the sum what will be the overall impact. So basically 2 to the power I, that is 1 left shift I we can do, 2 to the power I can be written as 1 left shift I also. So this will be the impact of this particular ith bit. That is, the impact will be 2 to the power I, and whatever number of pairs we are going to have, so that many times it is going to get added inside the sum. So suppose if I had 5 pairs, so 5 times that particular bit will contribute to the final sum. So that is why I'm multiplying it with 5. And once this is done for all the positions, then in the end we can simply return our sum variable. Okay, now let us try and quickly compile this particular code and see if it is working fine on the samples or not. So you can see it is working fine on our samples. Let's now try and submit this code to check if it is getting accepted or not. So you can clearly see that our code was able to pass all the test cases. Talking about the time complexity of my code, so now it will be what? 32 into n. Why the time complexity will be 32 into n? Because we are using the first loop for iterating through all the bits, and then the second loop for iterating through all the array elements. And we are not using any extra space, so the space complexity will be order of 1. So the efficient approach that we have applied is that we will check that how many numbers are there that have the ith bit as set. Okay, suppose that k numbers are there that have the ith bit as set. So the contribution because of the ith bit will be 2 to the power I, or you can say 1 left shift I. Now how many numbers can be made out of those k elements? So if k elements are there, and every time I have to choose 2 elements for making a pair, so kc2 will be the answer. That is k into k minus 1 by 2 number of pairs can be made, and those pairs will be having the ith bit as set. So this means that 2 to the power I will be contributed by that many pairs, right? So if one pair is going to be there, so it will contribute 2 to the power I inside the sum. So if suppose that 5 pairs are there, so it will contribute 5 into 2 to the power I. So whatever number of pairs are there, that will be contributed in the sum, and we'll keep on taking the sum, and at the end of the day we simply return our sum. This is a very good question, and I hope that you have understood the intuition and the logic behind it. Make sure to comment understood or +1 in the chat if you are clear with this, and thank you for watching this video, guys. Keep coding.